So in today's video, I'm going to be showing you how hackers can exploit your game and ways to prevent them from exploiting the game. In order for me to demonstrate how hackers can exploit your game, I've created a simple project with 3 scripts and a local script. And inside of the leader stat script, when a player is added, we create a folder and we give it the name of leader stats, and we parent it to the player. And we also create 2 number values, one called gold and one called apple, and we set the value to 0 and we parent it to the leader stats folder. Inside of the spawn script, we're creating a loop that loops every 2 seconds, and it will clone the apple mesh, which is inside of server storage, and it will position the apple mesh to a random position and parent the apple to the workspace, and then it attaches a function to the touch event, and when something touches the apple, it will attempt to get the player from the other part's parent part, and if it finds the player, which means it touched the character of the player, then we increment the leader stats apple by 1 and we destroy the apple that we cloned originally. Now let's look at the local trade script. So inside of the screen GUI, which is placed inside of the starter GUI, we have a text box and a text button, which you can see down here. And there's a script. And what this script does is it gets the text box and the text button, and we attach a function to the activate event that is fired when you click on the button. And what this function does is it converts the text box's text to a number, and if the text is not a number, we exit the function early, but if the text is a number, we send that number to the trade event, which is stored inside of replicated storage. And if we look at the trade script that's inside of server script service, we can see that when the server receives the trade event, it gets the amount that was passed from the local script, and we check to see if the amount is greater than the amount of apples that they have. And if it is greater, we say trade failed, not enough apples, and then we return out of this function. But if they do have enough apples, we say trade successful, and we deduct the amount from the apple and we increment the gold with the amount. Now let's play the game. And we can see that every 2 seconds the spawn script is spawning an apple, and we can see that my leader stats, I have gold and apple, and I have 0 and 0. And if I touch an apple, we can see that the apple value increased by 1, and I can continue touching apples to keep increasing my apple count. And if I attempt to trade my apples to gold by using this text box, and if I type the number 10 and press trade, we can see that it says trade failed, not enough apples. But if I type in the value of 2 and press trade, we can see that 2 was deducted from 5, so I have a remaining of 3 apples, and now I have 2 gold. So the first thing we need to know is a hacker can do anything that you can do in a local script. So for instance, a hacker could create a local script, and they could look among your local scripts, and they can see that you have a trade script, and they can see that you have a trade event, and they can see that you're passing a number to the trade event. So they could use this trade event in their own custom script. For instance, they could manually type a value of 1, and if we reload the script, we can see that they were able to trade without having to use the GUI. But for instance, a hacker may try to send different values to the server in order to bypass some of your checks. So if, for instance, instead of sending a number, they may attempt to send a boolean, and we can see that when we send a boolean, the server is getting an error. Or they may try to send some text, and we can see that this also throws an error on the server side. While these errors have no effect on our game, it's still good practice to check the type of the value that is being received inside of an event. And this is also a good way to check if a player is trying to hack your game. So I'm going to open the trade script, and at the very top, I'm going to check the type of the amount value. And if it's not a number, I'm going to print trade failed, and I'm going to print not a number, and then I'm going to return early out of this function. So if I play the game once again, and create a local script the same way a hacker can, and if I use the trade event and pass in a boolean value and reload the script, we can see it says trade failed, not a number, and the same should happen if we use anything other than a number. Trade failed, not a number. Now let's see what would happen if instead of passing a positive number, if we pass a negative number. So we can see that if I pass a positive value of 2, we can trade from 6 down to 4. But if I pass a negative value of -2, we can see that we can go from back to 0 gold and back to 6 apples. But if I do another -10 and reload the script, we can now see that I have 16 apples and -10 gold, which is not something we want our game to do, because this could allow a hacker to get thousands of apples, and if these apples had some kind of use to them, for instance restoring health, they could restore their health for an infinite amount of times. So inside of the trade script, after I've checked to make sure that the amount value is a number, I'm going to check to make sure that the amount value is above 0. So I'm going to type if amount is below or equal to 0, then print trade failed, and then print less or equal to 0, and then return out of this function early. So if I play the game again and send a negative value and reload the script, we can see that it says trade failed, less or equal to 0. Now let's see what would happen if the hacker sent a point value to the trade event. So instead of sending a whole number, I'm going to send a point value of 0.0001 and press reload the script. We can see that trade was successful, and we can see that we now have 0.001 gold and we have 8.9999 apples. And this may be something that you don't want in your game as well. So in order to fix this, after I have checked to make sure that amount is greater than 0, I'm going to floor the amount, and this is going to prevent the amount from being a point value and only be whole numbers. Now you may think it's impossible for a hacker to bypass these if checks to get to the trade successful part of the function, but there's one more value we need to test, and that is the NaN value. A NaN value is very strange in that if we attempt to add or subtract or multiply or divide any number by NaN, it always returns a new value of NaN. And if we check if NaN is less than NaN or greater than NaN, or if NaN is greater than 0 or less than 0, or if NaN is equal to 0, or even if we check if NaN is equal to NaN, it will always return false. So let's test to see what would happen if a hacker sent a NaN value to the trade event. We can currently see that I have 1 gold and 3 apples. And in order to create a NaN value, you can simply type 0 divided by 0. And if we reload the script, we can now see that the trade was successful. And we currently have NaN gold and NaN apples. And once we have NaN gold and NaN apples, we can now trade as many apples into gold as we like. And if I reload the script, we see that the trade was still successful and we still have NaN gold and NaN apples. So to make sure a hacker can't send the value of NaN to our event, after I've checked to make sure that it's a number, I'm going to check amount to see if it equals to itself. And if it doesn't equal to itself, then we know that it's a NaN value. It's also possible for Roblox's custom data types to have the value of NaN within them. For instance, if we was receiving a vector 3 value in this trade event, we would also want to make sure that the X, Y, and Z coordinates do not contain the value of NaN. So we could do this by checking it against itself and returning if the value does not equal itself. So now that we've secured our trade event, let's quickly overlook what it's doing. First, we're checking to make sure that the value is a number. Then we're checking to make sure that the number is not a NaN value. Then we're making sure that the number is greater than 0. Then we're rounding the number down to the closest whole number. And then we're checking to make sure that the player has enough apples to make the trade. And if all these checks pass, we then allow for the trade to be successful and we convert the amount of apples into gold. Now let's move to our spawn script and let me show you ways a hacker can exploit the touched event. So you can see that I'm in game and I have 0 gold and 0 apples, and there's apples being spawned, and a hacker could write a small script that loops every child in workspace, and if the child has the name of Apple, it can position that child at the position of the character. So let's run this script and we can see that now I have 25 apples. And if I run the script again, or I could even create a while wait 0.5 and put this inside of the loop and reload the script, and now the script will constantly position the apples where the hacker is standing, and they'll constantly increase the amount of apples that they own. Now you may think that if you anchor the apple, it will prevent the hacker from spoofing the touched event. So let's anchor the apple. So you can now see that the apples are anchored because they're floating in space, and I currently have 0 apples, and I've placed the hack, and if I load the script, we can see that it's still able to fire the touched event even though these apples are anchored. And the reason this is happening is because you may be thinking that it's the server's job to detect when the other part touches the clone part, the apple. But that is not the case. The client sends an event to the server telling the server that they have touched the apple, and the server will blindly accept that the client touched the apple even if it never really did. Now you may think by checking the distance between the apple and the other part and making sure they're within a certain distance before accepting this function would fix the problem, but it doesn't, because let's add the check. So I'm saying if other parts position negative the clone's position is greater than 10, then we're going to exit out of this function early before we increment the apple count. Now I'm going to comment out this anchored equals true, and I'm going to come into Studio settings and make sure to enable R region shown to true and test the game once again. Now because we have R region shown set to true, we can now see the radius around the character where the player will receive network ownership. And if we enable our script and look from the perspective of the server, we can see that if the part is within the radius, the player has the ability to move that apple to the character. So in order to prevent a hacker from moving a unanchored parts, one way would be to simply anchor the part, but if you want your parts to stay unanchored, we could set the network owner to nil, and this will force the part to always be owned by the server. And now you can see that even if a apple is within our ownership radius, and I enable the hack and I check from the server's perspective, we can see that the apples are not moving, and Roblox even has a built-in anti-hack feature where the radius will decrease if a hacker attempts to move parts that it does not own. So this distance check is currently working, but the problem is, what if instead of moving the apple, the hacker moves its own character? So here you can see I've written a slightly different hack. We're going to keep looping every 1 second. We're going to find the first apple child inside of workspace. If it can't find the apple, we're just going to continue and skip the next loop. And if we do find the apple, we're going to set the character's C frame to the apple's C frame. So I'm going to reload the script, and now you can see that instead of moving the apple, we're moving the character to the apple. And we can do this a lot quicker, so I can do 0.1, reload the script, and now you can see that the hacker can still collect apples even though they have no ownership of the apples, and we have a distance check. So the reason this is happening is because the other part, which is the part of the player's character, is owned by the player, and because they have ownership, they have permission to position that part anywhere in the world, and the server will blindly accept that position as being true. One way to prevent a player from positioning their character anywhere they want would be to set the character's network owner to nil so that the server owns the character. So if I make a new script and if I call this character and delete this first line here, and now I'm going to assign a function to the player added event and also assign a function to the character added event, and I'm going to spawn a function because I need to give a small amount of time for the primary part to be added to the workspace, and then I'm going to set the primary part's network owner to nil. So if we test the game, the first thing we'll notice is that the character feels very unresponsive, and that is because we no longer have ownership of this character, and it's now the server's job to update the position of this character. But now if a hacker attempts to move their character to an apple, so if we load this script, we can see that the character is being moved on the client side, but if we look from the perspective of the server side, we can see that the character is not actually moving, and if we try to walk, we get teleported back to the original position. So setting the network owner to nil has fixed our problem, but has created a huge problem that the character is now unresponsive. So this is almost an unacceptable method of fixing this problem. So instead of setting the character's network ownership to nil, a better method would be to allow the player to have ownership of its character, but to keep track of the character's position and detect if the character moves too quickly. And if the player moves too quickly, then we're not going to accept the position of the character. So under server storage, I'm going to create a new module script, and I'm going to call this script anti-hack. And inside of this module, I'm going to create a function, and it's going to be called set, and we're going to pass in a part and a maximum speed that we're going to allow the part to move. And then we're going to save the position of the part as an attribute on top of the part, and we're also going to save the max speed, and we're going to set the current time as an attribute on the part. And now I'm going to create a second function called getPosition, and this is going to be a function that we can rely to have a correct position, and we're going to get the position and max speed attributes from the part. And now I'm going to get the amount of time that has passed since we set the time attribute till we call the getPosition function. So I'm going to do this by saying delta time equal time negative part get attribute time. And now I'm going to work out how far they've moved since we last set the time. So I'm going to say magnitude equals part.position negative position dot magnitude. And now I'm going to use this delta time and magnitude value to work out how fast they must have moved in order to get to this new position. So I can do this by saying speed equals magnitude divided by delta time. And just for testing purposes, I'm going to print this speed value. Now I'm going to check the speed value to see if it's greater than the maximum allowed speed we've given this part to move. And if it is greater, we're going to simply return the old saved position that we can rely on as being a safe position that the character is in. So to do this, I'm going to say if speed is greater than max speed, then return position. But if the speed is less than max speed, then we can say that this new position is a safe position that we can believe. And what I'm going to do is update the position attribute with the most recent position. And I'm also going to update the time with the most recent time. And then I'm going to return the most recent position of the part back to the getPosition caller. So now that we've finished our anti-hack module, let's go back to the character script where we were setting the network owner to nil, and at the very top I'm going to require this anti-hack module, and instead of setting the character's primary part ownership to nil, what I'm going to do is delete this, and I'm going to use the anti-hack module to set the character's primary part. So I'm going to say anti-hack.set character primary part. And for the speed, what I'm going to use is inside of starter player, we can see that there is a value called character walk speed. So I'm going to use this speed to determine what speed to set this part to move at. So I'm going to say game.starterplayer.character walk speed, but I'm also going to add an extra 5 as a margin, because if the game is laggy for that player, the speed that they walk may be slightly different. So given a small margin will help to prevent false positives. I'm now going to go into the spawn script, and at the very top I'm going to require the anti-hack module. And instead of using the other part's position that we cannot trust to be the correct position, I'm going to use the anti-hack to get a position that we can trust. So I'm going to say local position equals anti-hack.getPosition player character primary part. And I'm going to replace this with the position variable. So if we test the game now and we look inside of our character and we select the primary part and scroll to the bottom, we can see that it has 3 attributes: the max speed and position and the time that this position was saved. And if we touch a apple, we can see that the position was updated and the time was updated. And it also tells us how long it took us to move to that new position, which was a very long time. But if I walk as fast as I can, we should see that this speed gets close to 16, which is the maximum speed my character is allowed to move. So you can see it's around 15.7. Now you can see we have an error where we have a value of nan. And the reason we're getting the value of nan is because when we calculate the delta time, there is a chance that the delta time will be 0 if we call this getPosition function 2 times in a row. And here you can see we're dividing by delta time, and you know that we cannot divide by 0, so speed will have a value of nan. So to fix this problem, what I'm going to do is I'm going to say math.max, and alongside of this value I'm going to store a value of 0.01. So what this function is going to do is select either this value or this value depending on which one is higher. So if this goes down to a value of 0, it will select the 0.001 value, so delta time has a 0 chance of being a value of 0. So now that we have our anti-hack script up and working, we can see that normal players that collect the apples normally will stay within their maximum speed limit. But if a hacker comes along and adjusts their humanoid walk speed to a high value like 40, and now you can see that the speed value is greater than the maximum allowed value of 21, so the apple was not collected. But if they walk slowly like a normal player, then they are able to collect. But if they walk too quickly, they are not able to collect, and they will have to wait until the speed time gets reduced to the allowed. So once this hits 21, then they will be able to collect. And now you can see once it hit 21, they was able to collect the apple. There is also another type of hack that a hacker can do, but in order to demonstrate this, I need to make some changes to the project. So inside of the spawn script, instead of using a touch event to detect when a player wants to pick up an apple, we're going to use a remote event. So I'm going to comment out this touch event, and I'm going to create a new remote event inside of replicated storage, which is called pickup. Now inside of starter player and starter character scripts, I'm going to create a new local script, and I'm going to call the script pickup. And inside of this script, I'm going to get the character, and I'm going to attach an event to the character's humanoid, which is the touched event, which will detect when a part touches any of the character's parts. And if the part is an apple, we're going to send that apple to the pickup event. And now on the server side, let's create a script for the server side. And I'm also going to call this script pickup. And this script is going to detect when the pickup event was called. So we're going to say game replicated storage.pickup on server event, and we're going to connect a function. And just like our trade script, where we check the amount value to make sure it's the correct type, inside of the pickup script, I'm going to do the same to make sure that this part is really a part. So I'm going to say if type of part is not equal to instance, then return. And I'm also going to check the class name to make sure that the class name is of type mesh. So I'm going to say part.className not equal to mesh part, then return. And I'm also going to make sure that the name of the part is equal to Apple. So I'm going to say if part.name is not equal to Apple, then return. And now I'm going to check the distance between the part and the player's character, which we already did inside of the spawn script inside of this touch event. So the first thing we're going to need is this anti-hack module. So I'm going to copy this over to the pickup script. And here you can see where we're getting the position and checking the magnitude to make sure it's under 10. I'm going to copy this and paste this here. And I also want to rename this clone variable to be equal to the part variable. And inside of spawn, we can see that we're incrementing the Apple stat and destroying the clone. So we want to do the same on the pickup event. So I'm going to change this clone value to part. Now, if we test the game and we touch a apple, we can see that it worked, but we received 4 apples for a single apple. And your first reaction may be saying that we need a debounce. And while a debounce would work, it's only a band-aid for the problem. So let me show you why a debounce is not the correct solution to this problem. So inside of the pickup script, let's add a debounce. I'm going to say local debounce equals empty table. And at the very top, I'm going to check the debounce, but I'm going to use the player as a key so that every player has an individual debounce. And I'm going to say if debounce equals true, then return. And if the debounce does not equal true, at the very bottom, after all these checks have passed, I'm going to set the debounce to true. And then after I destroy the part, I'm going to wait 1 second and then set the debounce back to nil. So now that we've added a debounce, when I touch a apple, the apple only increments by 1 instead of incrementing by 4. But let me show you why a debounce is not the correct solution for this problem. So you can see that in the game we have 1 apple here, and as a hacker I can create my local script, and I can also create a object value just so it's easy for me to select the apple. So I'm going to create an object value and I'm going to rename this to object, and I'm going to use this object value to select the apple so it's easy for me to reference it in the script. And then I'm going to call this pickup event using the object value's value to reference the apple. So I'm going to say gain replicate storage pickup, and I'm going to use the script's object value. So if I reload the script, we can see that the apple disappeared and I was given 1 apple. But now that the apple is gone, I still have a reference to the apple that was destroyed. So if I call this script once again, we can see that even though the apple was destroyed, I'm able to pick it up. And you can see that now I have 2 apples. And if I wanted to, I could make a loop like so. And if I reload the script, and we can see that we can only pick up once the debounce has stopped. So you can see that every second I'm getting 1 apple. So the reason this is happening, even though we're destroying the part is still available in memory. So when the client sends us the location in memory where the part exists, the server still has access to the part's class name, and position. So all these if checks are still passing and allowing the code to get down to this part where we increment the apple value by 1. So instead of using a debounce, so let's first delete this debounce code. It would be better to check to make sure that the parent is not equal to nil once we make sure that the part is a instance. So here I'm going to say if part.parent equals nil, then return. And now you can see that even though we have no debounce, we still can only collect 1 apple at a time instead of 4 when we touch the apple. And that is because if we send the event twice, on this second time the apple would have been destroyed and the parent would have been equal to nil, and this will also prevent hackers from collecting the same apple over and over again. Thank you for watching the video, and if you have any other questions, feel free to leave a comment down below.